graphing based upon the equation of a circle. And so sometimes we're going to have to take the equation, we're going to have to break it down to kind of its component parts to understand it. So as we look at question number 1, we've got x squared over 36 plus y squared over 4 equals 1, which is the form that we want out of the equation. Whenever we start to see this, you know, and it's not in this form, we're going to have to try to convert it to this form. So if you've got that, we're going to move over to another page. I'm going to show you how to kind of dissect this. We've got x squared, hopefully, there we go, 36 plus y squared over 4 equals 1. So if we want to find, we're trying to draw an ellipse, and so the first thing we need to find is we need to find the plus and minus of the x, the plus and minus of the y values. All right? And so the first thing that we're going to do is we're going to substitute in 0 for x. So we're going to get 0 over 36 plus y squared over 4 equals 1. And of course, 0 divided by 36 is going to cancel this part out. So what I'm actually dealing with is y squared over 4 equals 1. That's going to give me my y values. What would we do? I mean, we're trying to isolate y, so we're going to end up doing what? Multiplying by 4. So we get y squared equals 4, and we want y. So we're going to do what here? Square root. And because we're square rooting the y, what two values should I get for y? Positive and negative. Positive and negative what? 2. All right, so that means that on a graph, I'm going to go up 2, and I'm going to go down 2. Okay? Then we're going to end up doing the same thing, except we're going to plug in 0 for y, and we're going to solve for the x values. So as I kind of erase some of this here, make room. Okay, we know y equals plus and minus 2. Okay, we get x squared over 36 plus 0 over 4 equals 1. Okay, obviously that cancels out. We get x squared over 36 equals 1. We multiply by 36 on both sides. We get x squared equals 36. Okay, we square root the x squared. We get x equals positive and negative 6. All right, which means 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, and it's going to look like that. All right, looks like Hey Arnold's head. Okay, so what I'm going to tell you here is that in most of these cases that we're going to look at, whenever we get our equation into this format, I can look at this and say, well, I know that x is going to be plus and minus 6 because it's the positive and negative square root of the denominator. Okay, and my y is going to be the positive and negative square root of the denominator under y. Right, so I can begin to kind of fast forward through some steps because I know how it works, and it should work this way every time. Okay, does that make sense? So that should save us a little bit of trouble. Now, let's, from here, in your page, you should see it says number 2, write the equation in standard form and graph the ellipse, and it says 36x squared plus 16y squared minus 576 equals 0. Now, on all of these equations, we have a fraction plus a fraction equals 1. Okay, that's the standard form of the ellipse. So the first thing I need to do is I need to be able to get 1 in on the other side, right? And you'll notice in here, what I want to start off by doing is adding 576 to the other side, right? So that I'm getting 36x squared plus 16y squared equals 576. Okay, now because I want 1 over here on this right-hand side, the only way for me to do that is to divide everything by 576. Does that make sense? Right, so I'm going to divide by 576, divide by 576, because that's the only way for me to get 1 on the other side. And because I'm dividing the entire equation by the same number, I'm keeping my equation equivalent. You follow me? All right, so this will equal 1. Now I need to take 36x squared and divide it by 576, 16y squared, and divide it by 576, because the more complicated part that we need to understand here is that the standard form of the equation will only have x squared in the numerator. Okay, so a lot of these will work out really neatly that way. They'll have 1 in the numerator. Some of them later on will be more complicated because I do have to be left with x squared in the numerator. So what's 36 divided by 576 as a fraction? Okay, so the way we're going to write that is x squared over 16. You follow me? All right, so we just won't put the 1 up there. And 16 divided by 576. 136. Y squared over 36 equals 1. Okay, so it says write the equation in standard form. We've done that. Now, because we're familiar with how these equations are going to work, okay, my x value is going to be positive and negative what? 4. And my y value is going to be positive and negative 6. Okay, so I'm going to go to the right 4, left 4, up 6, down 6. Right, and I'm going to get something that looks like that, okay, except better. Does this make sense? Okay, we can go through that pretty quickly. All right, that brings us to question number 3. Let's see. We should be able to solve this pretty quickly, right? All right, let's see. Marcus, can you tell me what the x value is going to be based upon that equation that they show you on number 3? Positive and negative 5, right? Okay. Ryan, can you tell me what the y value is going to be? Positive and negative? Positive and negative 8. Okay, so it wants the graph. Can anybody tell me, based upon the ones that you see there, we don't necessarily have to draw it, which one of these graphs matches that? D. D. Okay, so we feel like that's fairly easy, correct? All right, if it gets to be any more complicated in the homework, let me know. I'll work those out with you. Okay, like I said, some of them can get more complicated if, for instance, whenever we reduce that fraction, let's say it came out to 4/5, would have to work that out in such a way that we're going to be left with x squared up there. So we'll have to do some kind of mental gymnastics there, or not mental, but mathematical gymnastics to get x squared alone in the numerator. Okay, and I'll show you how to do that if we get there. Okay. All right. The last couple questions down here, numbers 4 and 5. Says solve triangle ABC given A equals 47 degrees, B is 44 degrees, and side B is 74. Same kind of similar situation with 5. All right, so this should be review for us, but I'll go ahead and put it up here. This is what is referred to as the law of sine. I don't know how many of you remember the law of sine. A couple of us. What that is the sine of angle A over side A is proportional to the sine of angle B over side B is proportional to the sine of angle C over side C. Given that in a triangle where I have angles A, B, and C, the side opposite angle A is side A, the side opposite angle B is side B, and the side opposite angle C is side C. So hopefully we remember how to draw a triangle and how to set it up, even if they don't draw a triangle for me, correct? Okay, so they show me a triangle, or at least they talk about a triangle here, and they say we've got triangle A, B, and C, so I'm going to start off by just putting A, B, and C in here, and then putting in my information so I know what we're talking about. A is 47 degrees, okay? B is 44 degrees, and side B is 74. Okay, we have side C over here and side A right there. All right, it's asking us to solve the triangle, which means whenever they say solve the triangle, they mean solve for all the missing parts. We have three missing parts here. We have angle C, we have side C, and side A. Okay, what's the easiest thing to solve for in that triangle at this point? Angle C. How do I do that? All right, so 44 plus 47. Okay, that should be what, 91 degrees. Okay, so those two things add up to 91 degrees, which means how many degrees should we have left for angle C? Something like 89. Okay, all right, so 180 minus 91 is 89 degrees. Okay, so we've got that part of it solved. For the rest of this, we're going to have to use the law of sine. Okay, so let's set that up down here. JP, what do you want to solve for? Do you want to solve for side A or side C? Side C. Okay, so tell me how you would begin to set this up to do that. I wouldn't start there, because what you want to notice is if you're going to use sine 47, then you have to know. I can't have two unknowns in my proportion. So if you were going to solve for side C and you started off by using sine 47, well, we don't know the length of A, right? So then I'd wind up with sine 47 over an unknown equals sine 89 over an unknown, right? We have to start off with an angle and a side that I know both parts of. So is there an angle and a side opposite of it that I know both? Yeah. B. All right, so let's do that. Sine what? 74? Should be 44. Oh, sine has to be the angle. Over. There you go. Sine 44 over 74. Now, you wanted to solve for C, right? So equals what? Sine C. Well, we know the angle. Over C, right? And because it's proportions, how do I solve proportions? Cross multiply and divide. So what I'm going to end up writing in my calculator is 74 sine 89 divided by sine 44, right? Right? Now, before I go and do this, just because it's been a little while maybe since we've done some things like this, I need to check in my calculator before I start punching a bunch of stuff in. I want to make sure it's in degree mode, okay? Because believe it or not, even if you didn't change it to radian mode, sometimes your calculator will do that for you. All right, so what is 74 sine 89 divided by sine 44? $106.51. 106.51 is correct. Okay, now we need to find side A. Let me hit pause on this here for a second and answer the phone. All right, so for this last part, I would always say, don't, even though we found 106.51, I wouldn't, all right, so what I was trying to say is that when we get to this situation, I want to find side A. I'm going to continue to use sine 44 over 74 because that was given information. I don't want to use found information to set up the next proportion, right? I don't want to use 106.51 and 89, right? Because I had to find both of those things. So I'm less certain about those than I am, sine 44 over 74. Does that make sense? So all I really need to change to do the next part is just change the proportion over here. I'm going to keep this other, and we're going to do sine 47 over A. And of course, at this point, all I need to do is 74 sine 47, sorry, Liz, divided by sine 44. They called me like 2 minutes after I sent you down. They're like, yeah, we don't need her. So if you have like a Fitbit, you got some extra steps in today. All right. 74 sine 47 divided by sine 44. What do we get there? Okay. Would it be like 77.91 if you took it out there? Okay, and they don't say to take it to that many significant digits, but that's the answers that they come out to. So we needed 106.51, 77.91, and 89. So that finishes the triangle out. Okay. All right. So that leaves us with our very last question, which is solve triangle ABC, given that A is 50, B is 52, and B is 66. Same thing. You'll notice here that they give us both parts of B. So that's the proportion I want to set on the left-hand side is set up sine 52 over 66, and then swap out the other parts. Again, they don't give me angle C, but once I've done that, right, I can tell, okay, 50 and 52, that's 102, right, out of 180 degrees. I'm probably going to need, what, like 78 degrees left. So I know we're going to need 78, so it's either A or B. So the rest of it is just setting up those proportions and solving. So what I'm going to do from here is I'm going to hit pause, or I'm going to hit stop on the video. And before you guys go on and do your homework, I want you guys to give me your answer for question number 5. Can we do that? Okay, give you, close to 20 minutes to work.